Yeah. So this is kind of weird. They said, "Can you do a talk at the end of the day?" I was like, "Sure, I can do it." And they're like, "And we're going to serve beer for it." I'm not sure how to interpret that, but anyway, I'll try to stay on the soft side. I know it's the end of the day, and well, you're all drinking. So what I wanted to do here was more like share, like any software project, or I guess any engineering project, you have a series of goals in mind, and you have a bunch of ideas, and of course, at any point in time, there is a bunch of ideas you said, we're not going to do those ones, we're going to do these ones because they're great, and then a few years pass and they don't look so great. So I just wanted to do a little bit of a recap, and I'm sure there's a lot more, but these are some of the ideas I can remember that some were really good, some were really dumb, some saved us, some we're still trying to explain why we have the feature. So some of the good ones that I'm going to try to stay short on this side because it's too easy to say, yeah, this thing is awesome when just trying to reach for something. So I think we have many principles. There is some folks here that you go into a design discussion and they go like, whoa, 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 stop. What's the principle here? So there's all these discussions about what are the guiding principles, and there is a point where you have so many that they don't count as principle anymore. But if I had to rescue one that has been useful kind of across all this exercise, has been this thing of, look, reality is that software systems model reality, and very rarely reality is that simple. The trick is, how do you create an infrastructure that allows you to keep simple problems simple and stretch as the sophistication that is intrinsic to the problem grows? And a way I'm trying to articulate this principle is to say, look, simple cases need to stay simple. But that doesn't mean that you don't do difficult stuff. Difficult stuff happens. The trick is to only force people into difficult stuff if the problem at hand requires that level of sophistication. And my favorite example of this is this. So we have, 5 years of OData. So 5 years of adding feature, 5 years of all these guys over there typing nonstop, adding things, teaching new things to the system. But still, if you have this collection in some system that you don't need to know what's going on inside, and the collection has a few fields, and you want to create a new entry, you just take curl, do a post, or your favorite HTTP client, do a post, build this little JSON object, precisely this, there's nothing else, no control information, no out-of-band knowledge, nothing, just this. And the thing just works, and it does what you expect it to do. So these things are important. This means we're not taxing for things you don't care. Of course, once you get sophisticated, you invariably have to make more choices. And then the question there is, well, do the choices match up with the problem and your preference? But simple things should stay simple. So this is one of them. The other one that has actually held up pretty well is we argue that it is actually possible to build data-centric service interfaces on top of applications, not just stores. I mean, of course, you can put a SQL store and abuse SQL to the point that you make it do all these crazy things, and we've done plenty of that too. But there is also, can you put it on top of apps so that you turn, traditionally, service interfaces for apps have been very, method-oriented or action-oriented, however you want to call it. And oftentimes it's for good reasons. Sometimes you want predictability as the primary feature, and you don't want anything to happen that you didn't plan for ahead of time. But sometimes you want to enable people to get creative. And for that, what you want to do is say, here's all my data, here are the rules that govern accessing this data, but not the policy, just the underlying rules, not how to use it. Just go be creative on how you use it. And I think this has helped a lot that. And we've seen this being successful out there often, and it's nice to see it happen. It's difficult, and many of you have implemented OData surfaces over non-queryable surfaces, and this is hard work. But the output we've seen it to be very effective for the consumers of that technology. Commitment to HTTP. You start anything that does networking, and there's the discussion of the layers. How many layers? How much independence are you going to have? Can you swap it? Can you swap the transport? Can you swap lower below? Can you swap above? What assumptions are you making? So one stake in the ground we put very early is we said, no, look, this is an HTTP protocol. You can kind of make it work over a non-HTTP transport as long as it looks exactly like HTTP. And you can do some of that but to some extent, we don't, we made a choice about a particular protocol, and I think that has paid off. It paid in simplicity, it paid on good integration on the web and in general with the existing infrastructure. The other one that I know this, I don't know if all of you guys are in one camp or they're spread across both camps. I've heard a lot of camps around metadata and whether or not having extensive description of a service is a good thing and a useful thing or not. In the SOAP services, description was fundamental because of the way bindings work and things like that. Either you have it from the server or you have it locally, but it was the only way to work reasonably with a reasonably complicated service. In many of these current web services that are simple HTTP services, some call them like REST services or something, the reality is that this is not needed because the service itself is so simple. You go to Twitter, and the API for Twitter is you do a get from something and you get a list of objects, and that's it. So why describe it? And that's probably a good call. The reality is that if you want to create an ecosystem of tools that will save you time, having a declarative infrastructure actually can be very powerful. It can help frameworks and tools get work done for you. So it requires larger investments in some areas, but the net is that as a consumer of one of these off-the-shelf frameworks or tools, you get a lot of benefit out of it. Especially, this is not so much for the Facebooks or Twitters or this large one-off APIs. It's more for everybody else, all of us that we're not one of those that have kind of a large proportion of the internet traffic, and so you want to have users hit your infrastructure without having to ask them to go write a bunch of custom code. So a weird one, and this is the last I have on the good side. We actually did versioning in the first version rather than waiting for V2 and then kind of somehow work it. This actually has saved us a couple of times already, and I'll try to touch on one or two of those. We did a couple of things with versioning. We didn't try to get too fancy, and compared to other versioning schemes like the SQL Server versioning scheme, the scheme we use actually requires less from servers and clients. But the primary thing it does is it puts enough information on the wire on both sides that enables each side to independently make sure that you're not going to misinterpret a message. We're not trying to negotiate individual features or things like that. It's more along the lines of if you receive a request, before you look at anything, if you look at the version number, either you know about it or you should not be looking at the payload at all because you may misinterpret it. So it's this one rule, very simple scheme, and it actually works really well. The other thing it lets you do is if you actually have the other end communicate to each other the maximum version they support, you can cause someone to fail remotely. So for example, a server can actually return to a client a version that is too high, and you can be sure the client will fail when processing the response. But if you know the version of the client on the server side, you can actually fail on the server and tell the client what's going on. There was enough information on the wire that this actually has held up really, really well over the multiple versions we've worked through. So enough of the good. Some of the bad ones. So the first one is there's some clients out there, and I'm maybe responsible for some of them, that don't do the versioning headers. And ignoring the versioning scheme is too easy within a single environment because your servers and your clients are in the same version, especially you're in the current version, it matches the documentation, so you think you're all good. Until we use the versioning wall to protect clients from misinterpreting a version bump, where the problem is not the version number, is that the data may look like one thing, but actually means something else. So you think you're parsing the thing correctly, but in the end, you're getting the wrong sense of what it means. And so this has happened in practice with something called server-driven paging. So the feature is it's pretty simple. If you do a get on the server, with or without a filter and all that, the server may have a very large amount of data. In fact, there's a rule in OData that says we do not make assumptions about the size of the data in the backend. And this permeates the stack, and I'll talk a little bit more about this later. So if the filter is such that it doesn't have enough selectivity to make the response relatively small, then you can make the server do a lot of work and return a lot of data. And especially for services exposed to the web, that means that you are unprotected from either a simple vector for attacks where people pull a lot of data from you, or even from a bad quality client where the client doesn't know to slow down the amount of data they're getting, so they just keep hammering your servers with these requests. So what we did to address this in the version 2 of OData is we said servers are allowed to return a partial result. And the question is, well, how do I get the whole thing if I actually meant to get the whole thing? The way you do it is there is a continuation. There's this next link, and the server encodes whatever it wants in that next link. So this is kind of an outline of the response, kind of an informal format. So in V1, you would get all the entries at once. And if you exceeded some limit, you would just get an error or something. In V2, we said, actually, we're going to give you some data and then a next link. And clients that want to actually scan the entire result set follow the next link and keep parsing. And then there is another one until eventually there's none. And then you know you're done. So a small application on a phone will probably not follow that until the user kind of falls into it by scrolling or something. Excel actually knows to follow them so that it actually pulls the whole thing down. Well, the problem with this is if you're a V1 client and you don't know about the next link, you can parse this successfully. Because you most likely your code just doesn't look for this. It's not like your code looks for everything that is not supposed to be there. Especially the next link, because the next link is a legal element in Atom. So even if you enforced it by an XSD to actually check for everything that wasn't supposed to be there, you would still have this problem. This thing will parse successfully, and you think you have the whole result, but you don't. There's no failure in the system, you just lost data. So what saved us here, it would have been much better to think about this first, but what saved us here was that we have our versioning scheme in place, and what we do now is if we see, like, there is a series of rules where we can speculate that we might need to put a continuation link on the wire, and if we do, then we bump the version of the response to V2. So V1 clients reliably fail, which is a lot better than giving you the wrong response. So now that means that you can upgrade your clients and your servers at different speeds, either one first. Yeah, you may see some failures, but you're guaranteed not to make mistakes on your data. And in fact, if you round trip this, you may corrupt data and all that. So this has actually worked really well, but it was pretty bad that we missed the server-driven paging thing. In retrospect, it was a pretty obvious requirement. So the other one that we have this problem all the time, and guys were there laughing because we're going through this now with JSON Lite as well. It's easy to put yourself in a corner in JSON, much more in JSON than in XML, where you don't have spots to put stuff. Like the problem is, you rev the protocol, there's always something you need to say and you don't have a place to say it. Let me give you an example. Something.
Example.
Out of battery? That's pretty lame. Oh well. So this is the sketch of a simple JSON response in V1. So it was just an array. For security reasons that I can tell someone over years later, you have to put an object wrapper around it. But in essence, the response was the array. You don't consider the D object that is around this part of the protocol. That was just a kind of a transport thing. So now we go to V2 and we have the next link. Well, where do you put it? Clearly it cannot be inside of any entity. You can sort of do that, but that's not great. I mean, some of them are objects, some are not. A V1 client will choke because he will expect all objects, and one of them is not an object. So that's pretty sketchy. So the problem here is an example of a pretty common problem where in JSON, you can't just add an element or an attribute anywhere. You have to find a spot. Like what we did here is like this didn't make much sense. So we had to add results wrapped around the thing. So basically, we made the whole thing an object instead of an array. And then we had a results property that had the results, and then a next link with a link. And this is just an example. More in general, the problem is you have to, in JSON in particular, you have to carefully plan ahead on where are you creating yourself space for future versions that will need to carry extra information that may not apply to the same layout of object that you have today. In the JSON Lite format, where we got the opportunity to go for a bigger change of how we serialize things in JSON, what we did is we kept a lot of this in consideration. So you'll see some object wrappers. We don't want to add extra noise. So to balance the two, what we do a lot is we have these annotations. So we have some properties that are regular properties, and some properties that you'll see that are of the form, some property at some value, or OData dot metadata or things like that. And what those do are they add information about the object that is the peer object, the object that is containing this annotation. This allows us to that combined with having objects in the right places allows us to always have a spot where we can add future control information if we need to. So another one that has been the source of a lot of work is ambiguity on the format. And this is, so today, if you take an OData client, like .NET client or most of the clients out there, they actually successfully work and they parse everything. The problem is, like from the protocol definition perspective, it's not crisply defined how much do you need to know and where that knowledge comes from in order to parse any one specific response that comes from a server. So, like, for example, the .NET client uses some information from the wire, but it also uses some information from the .NET object model you're using on the client. And it may use information from some other place. So the question is, like, we have events, and we call the events, and we use those to also add information, like namespace resolution or whatever. So we wanted to make it so that there was a definitive way of parsing one of these things with no heuristics, like crisp definition of where you are and what kind of thing you're parsing. And we wanted to establish what was the source of context, not just this organically grown thing of a little bit from here, a little bit from there kind of thing. So in the end, what we did, this is in particular in JSON Lite, which is the one format we created after a few iterations of causing some harm in the other ones. Every data instance we exchange on the wire carries a URL that A points to the metadata, making it self-contained, and B, after the metadata URL, there is a hash mark, and it points to the schema element in metadata, such that it fully disambiguates the nature of the payload. So that means that if this makes no assumption about who created the URL and who issued the request, or how much you know on the client about the type system. Given that response, regardless of how it happened to make it to your system, you can take the URL, pull the metadata, use the metadata to guide your parsing, and then use the information after the metadata hash mark to tell which kind of construct you're parsing, if it is a feed, an entry, a property, a link descriptor, or anything like that. So that this should make writing formal sound parsers a lot better. And the reality is that vast majority of people will never care about this. But for those that do, it's a headache not to have this. So finally, there are a few of the ugly ones, and it was tricky to categorize in, like, especially the line between bad and ugly is kind of weird. So I went for bad are things that were just plain bad ideas. Ugly are things that are somewhat bad ideas as well, but they work. The problem is they may not have been the best choice. And this is the best one. This is probably the most obvious one. So we have parentheses in our URLs. And I'm sure a lot of people notice that. And people go, and I've heard statements in the full spectrum from, look, you have parentheses in URL. You're not RESTful. And I'm like, I don't know. I mean, is this a discussion we need to have, parentheses and REST? What's the relationship? All the way to, look, your URLs are really ugly, which is a much more reasonable discussion to have. So there's some history. I mean, at some point they actually made more sense than they make now. The reality is that if you look at the URL, the path part of the URL before the question mark, even though it looks like a generic thing, there is a little bit of an algebra there. There is three operators. There is the member access operator, which is basically anything you do after a slash. There is the kind of item lookup operator. There is given an address that addresses a collection. You have an operator that picks one item out of the collection by providing the keys. And by default, it's the parentheses. And then in V3, there is the cast operator, which is a namespace qualified type name. It also goes in a segment. So there is some principle to this whole thing, but there is two problems. Syntactically, it's just unusual, and it throws people off. And I think that's the biggest problem, even though there is an underlying technical problem that people focus less on, which is by using parentheses for keys, we traverse one hop of the namespace without making your relative URLs work. If you use a slash instead of parentheses, then you get to use relative URL composition, which we don't get to use here, and we're paying for it in the JSON Lite version. So this is one that it was I mean, it works, but we could have done better with other syntax choice. The good thing is that since in JSON Lite we're decoupling the URLs from the clients completely, so that not only some of the URLs are opaque, but all URLs can be considered opaque. Then people get to choose. And depending, some implementations will have more or less flexibility, but at the protocol level, we're saying URLs are servers call, which I know some people will say, yeah, you should have done that since day one. It is what it is, but we're getting there now. You have a question.
No, I was just going to comment that from what I recall reading on OData.org and maybe even in the spec, what I read goes to great pains to say that this is merely a convention and not required by the protocol. Now, that doesn't mean that every implementation out there respects that. But isn't that the case, that this is simply a convention?
Yeah, absolutely. This is so the question is, the spec says this is a convention, it's not a requirement for the protocol. Yes, this is the protocol says may, I think, for this. So it is a convention, and you are compliant without it. And clients will work to a certain extent if you don't follow this. Like the .NET client that we have will execute a query as long as you give the URL, will download the objects, will materialize them. You can even change them and push the changes back, and we'll do all that with no knowledge of the URLs. There is some areas, like for example, our link provider.
Asterisk on that one.
What's that?
I said put an asterisk on that one. At least the WinMobile Subbin client has cases where it actually fabricates up.
It fabricates a URL? I thought it was only in attach.
No, it was.
We
counted it just to get.
We should sit down with a computer and take a look.
Reflected through the code, and we're like, oh man.
Oh, that's pretty lame. So yeah, we should take a look. So the places. I mean, there's one harder to explain spot which is attach, and that's just wrong. But the other place is the link translator, for obvious reasons, makes assumption of the server URL space, because well, the link translator is an easy way of producing URLs. Now, in the new version, we are describing this declaratively as well. So you don't need, even for the link translator, we can get away with not producing this in the URL. And let me give you an example of that. So I missed this slide on my previous presentation, so I just inserted it back here.
You
Andy.
clarify the new version before you...
Yeah, I meant in the one that we're still working on. Yeah, yeah, not the one we're about to ship. Sorry. So these are 3 examples of expressions that would show up. This is using the annotation syntax that Mike talked about before. And what this does is it says, instead of creating a convention for the URL, there is only the one convention that you have to read in a document. Servers get to say any convention they want. And clients that care about constructing URLs, they don't need to know the URLs. They need to know about this content type called CSDL. This is our metadata format. And following these rules, you can stitch together URLs for different operations. And in this case, this is using this XML is kind of funky, but it's using the parentheses syntax for this. But you can imagine just as well to use slashes for this. And once we have this document, we can actually feed this to the link translator. So this is actually pretty cool. You get to keep the decoupling between client and server, so no shared knowledge about URL schemes. But the link translator actually still works, or will work, once we're done with this. So I think I think that's a good step forward in that direction. It also means that you get to pick your URL scheme, and if you don't like the parentheses, you get to not use them. And I know some people are really passionate about this. So I'm just putting this here because Alex is in the room and he really, really wants to get rid of associations. Associations are complicated, and sometimes we wonder if we should just have navigation, effectively links, and say there is an object called a typed link, and that's it. There is no association sets and association types and so on. We need a lot more beer to discuss this, so so this one I wanted to touch on. So we briefly talked about datetime. I think one of you guys brought up datetime. So, man, JavaScript and JSON. I make 2 observations about JSON. So one is there is no datetype literal. So there is no way, unless you have out-of-band knowledge, there is no way to represent datetime magnitudes in JSON, period. So somebody has to know that the thing you put it in quotes.
There's no ways to represent a long either.
exactly. That was my second point about numbers. Actually, so numbers are also tricky because the JSON spec says a number is a thing that has some digits, a dot, some digits, and maybe an E and the E format. So that's the entire kind of description of a number. So it doesn't say anything about precision or scale or range or anything. So it doesn't really say it's a long or an int or whatever. It just says it's a bunch of digits. So should you truncate if you don't have that many digits? Well, it's like that's up to implementation. The problem is in a context like this where you need some interoperability, it's tricky to deal with that. I mean, browsers tend to, if you do a dot parsing, a JSON dot parse in the browser, you'll just lose some digits and silently, and you just can't find out. So the challenges are actually different. For datetime, the problem is you just don't know. So it looks like a string, and you have to either speculate or have out-of-band knowledge, which kind of hurts. I know the current format is difficult for other reasons, and I should have put that in the bad, not in the ugly, because you basically cannot produce it from JavaScript, which is not that impressive.
You can. You just can't use existing libraries.
So numbers are tricky because you tend to silently lose precision, which is pretty serious. So we're actively debating this. If anybody tomorrow wants to talk about JSON Lite, I'll be curious to share some ideas on this and see where we want to go with it. But the reality is that we have to make tough trade-offs. Either we do funky formats, or we do annotations on the side, or we kind of create the need for out-of-band knowledge.
I mean, I don't want to go into tomorrow's conversation
too
much, but I mean, it seems to me that when you get a currently OData formatted number like a long, it's coded as a string, right? An int is not because it doesn't need to be. Yeah. But I think some of the other ones are also coded. Well, when you get those on the client, you don't know from looking at the data, you don't know if it's a string, a number, anything. So why is data any different?
It's not. No. That part I agree. That should go in the bad, which is like, why do we have this special rule about date? I think more in general, the problem we have to deal with is there's some cases where you don't know the type even with metadata because of open types, and we have to handle that. But I agree with you that in the typed case where we have metadata, there's no justification for treating these guys differently. It was an interesting idea at the time. Again,
use a Unix time instead of
what's that?
number time.
I never understood why this forward slash is scaled.
Oh, why we do that particular format? It was there in ASP.NET Ajax, and we were good citizens of the company. That's all I can say.
Someone had dirt.
So the last two slides I have, and I want to finish 4:50 sharp. So one is streaming. We have this rule, this VTEX favorite rule, that says if you don't care about extreme cases, just buffer everything and have an easy life. Do something else. Don't worry about this. But if you want to be a hardcore, high-end system, the only thing you can assume regarding the size of the data you're manipulating is that one entity fits in memory at a time. No more, just one. So this seems easy, but you have to consider that entities in OData may be expanded. So they may have children that have children and so on. And the working assumption is that any one expansion is infinite in size. We don't want to assume anything at all. Because we want to effectively be able to stream infinite results. And we've seen people do kind of these stream-oriented things where the result set actually never finishes. So this is a hard requirement. The problem is how you achieve that. Again, if you don't need this, don't think about this. It hurts. But if you do, then this is a typical result. You have some feeds and then an entry. An entry is expanded, so it has a feed inside, and which in turn may have other feeds inside. And each one of them is independently unbounded. So the way we model this in OData Lib is we actually model the thing along the lines of an XML reader. It's like a cursor. And what you do is you cursor through each one of the spots. The problem when you do that is that you are creating a contract that in the past we've done kind of implicit, and that has caused a lot of pain. So now it's a lot more explicit as we work through this, where the ordering of things are very important. Because if, say, one of these nested navigation properties is infinite, you may get the type at the beginning before the thing and may be able to report it, or never because the nested thing is infinite. So now you have to create this very tight ordering set of rules on when do you put data on the wire, even at the same level, because you never know which one is going to go forever. So ultimately, the reality of this is, and there's a lot of fine print for anybody who wants to discuss the details. The reality is that very few libraries care about this. Those that do, if you can use OData lib, and if not, then you'll have to deal with this. Most other people, as I talked at the very beginning of in my first slide, then keep it simple and just buffer the thing. And once you buffer it, all these problems disappear on the spot. So my last slide with my last minute is I didn't know how to classify it. So this is a really funky thing that happens. We have some difficult people in the team. Being an architect on this team is very complicated. So I removed the names to protect the innocent. But these guys actually keep a Twitter thing called Architect Wisdom. So I took some of the statements that go in there without the names. And there's plenty more if you want to see. But there are some like, using it is not actually a typical use case. These are statements made during design meetings, just in context. So that makes you wonder. Or I'm not going to deny reality again. So this is regular practice. We have this, imagine for a second that crappy APIs are OK. Or this one is awesome. You start a pitch and you say, I'm going to start out with this very, very convoluted thought process, and then we'll go from there. And this is a team has, as a principle, that things have to be simple. This is a form of denial of reality. I know this makes content. Let's just not talk about this. We'll just push forward. Sometimes this happens, so you got to kind of give up and deal with the lack of abstraction. This is desperately looking for victory to be claimed. So, so there's non-zero progress being made somehow. Or just a plain out, let's just claim victory for something. And then people give a hard time to the author of this all the time, so I'm going to just clear it there. The web is a big place. People don't seem to be able to get past that one. There's a whole bunch more in Architect Wisdom. And with that, thanks very much for sticking around the whole day. And I think we'll see you guys on dinner later. Thanks.